So today we're going to be doing a period overview for Math 345 on Egypt, Babylon or ancient Babylonian Empire, and Greece. So for Egypt, I did the Rahan Mathematical Papyrus, and they kind of talked about the division practical. They used division in a very practical way. Um, a little different than us. They thought, like, for instance, they were trying to split the loaves, and he did splitting 6 loaves to 10 people, and he cut each one in half, and then the sixth one in tens. So it's kind of thinking of it in a more practical way than a mathematical sense. Um, Also, in this book, they divided 2 by 3 and by every odd integer, so like 3, 5, 7 to 101. In the sense of linear equations and being able to do those, they use more of a false position. It was common in that day, but it wasn't like our modern approach. It was more again, in the sense of practical. Um, they also, in this book, they did shapes inscribed in rectangles. That was a thing. Like, they did an octagon inside of the rectangle. And then they kind of came up with the idea of slope. They used a different word for it, but with pyramids, and that kind of brought the idea of slope up. The Moscow Mathematical Papyrus, they did a more modern approach with linear equations. It was much like what we see today, obviously a little different, but they did a more modern approach. They also came up with the volume of a truncated pyramid. So, again, using the resources and what they saw around them, very geographical kind of math. Um, they used that to kind of create the volume. And then they kind of came up with the idea of word problems. They called them work problems, but it's kind of our idea of, using a very practical illustration to be able to solve problems. They did an Also, they had 2 different types of number systems, but one was based on base 10, much like we see today. So they had different symbols for the 10, 100, 1,000, 1, so on and so forth. And naturally for them, they did the smaller number on the left. So it would start with like the ones, and then the tens, and then the hundreds and the thousands. Um, and then also, like I said before, they use nature, the layout of the nature, so the river and the patterns in the river, the pyramids and things, for math and for measure as well. And then onto the Babylonian, they came up with the idea of square roots. You kind of made a guess. You used the 2 formulas you see there, and you were trying to find the C, which was the very small error, to kind of come up with the square root, and you would kind of use the guess to be able to find that. Then the Pythagorean theorem, like triples, the Plimpton, I believe is how you say it, 322 table, the tablet, I call it a table, is what they use to be able to come up with those triples. They use the x squared plus y squared equals d squared, and then they use the u and the v to be able to find those. And then for geometry, they also came up with the area of triangles and circles. They kind of used those to be able to come to what they are today. And then they also came up with the volume of solids as well. And again, in their culture, they used the practical ideas to be able to do their math. And then for Greece, we see a lot of different people came into those. So, for instance, Thales, he did the height of pyramids, but he used comparison with the shadow and different measures on the pyramid to be able to create that. And then he also was the one that came up with base angles are congruent in an isosceles triangle, and then vertical angles are congruent as well. And then we see Pythagoras. He came up with the proof of the Pythagorean theorem. It is believed that it started before then, but he came up with the proof of it, and that's why it's called that today. And then he also came up with the idea of odd and even. So adding and subtracting two things that are different and getting something else. So with the odds and the evens, he came up with that idea. And then we see a huge one, which is Euclid, which he used his elements, the 13 elements or the books of elements that he used. But a lot of that, especially in the first book, was with our Aristotle's ideas in mind, as he kind of wrote them out. And he used axioms, common notions, and propositions to be able to create what he believed and what he thought was correct. And he used logical proofs to be able to prove things were correct and true, like his axioms, his common notions, and his propositions. And then he also came up with the idea of being able to do geometric algebra. So, using those geometric figures that we talked about before, volumes and base angles and vertical angles and all that, to be able to do algebra within them. And then, as far as number theory, he also did ratios and proportions and being able to use ratios and proportions and what those kind of looked like. And then also for Greece, Apollonius is how I believe you say it. He used cuts in a cone to be able to relate them to a parabola, hyperbola, and an ellipse. So he was a big guy on the conic sections and being able to create those. And he kind of is the first one that created that idea. And then we see Archimedes, which he estimated pi. He used bounds and created those upper and lower bounds to be able to create the idea of pi, and he came very close to what pi is today. And then he also used the law of the lever to be able to find the area of a parabola, which was kind of neat to see. And then we have Ptolemy, which he was a big one in astronomy, and he found angles between the equator and different things using his mathematical skill in astronomy. He also, back then, they used chords, and he was the one that he did his trig based on chords, but very easy to relate that to today. And he's the first one that came up with like a chords table, which was like a trig table in today's realm. And then he also did a quadrilateral and a circle, and kind of figured out how those would work. And he also came up with the idea of half angles. Again, today we went over Egypt, Babylonian, and Greece, and that was my historical overview. Thank you for listening.